Okay, so this is my circuits project. So for this project, I wanted to design a circuit which would indicate when a certain voltage potential has been reached across a capacitor. And a mechanism like this can be used in a wide variety of situations, but specifically what I had thought of is since the internal energy stored in a capacitor is directly related to the voltage potential across it, this could be used to indicate when a certain amount of energy is stored in a capacitor. But in this circuit, I will just be using an LED to indicate. So the circuit I came up with is the circuit that's on screen right now, and basically what it is on the right hand side we have a 4.5 volt voltage source, and then a single pole double throw switch, which has one of two settings. So the setting it's currently in, it will lead the current through a 100 ohm resistor, then a potentiometer that can go anywhere from 0 to 10 kilo ohms, and then that goes to a node which either goes to a 0.1 Faraday capacitor or a LED in series with a 1.5 ohm resistor. Once it is past this segment, it continues down to the node on the bottom side there, where if the switches as it is shown currently, the current will obviously not travel up that wire, but if it is, the current will bypass the voltage source and it will then travel through the 100 ohm resistor and the potentiometer, effectively discharging the capacitor. So for an RC circuit, we know that the time constant is equal to the resistance times the capacitance, and that the voltage as a function of time is equal to the force response plus the natural response minus the force response, times e to the power of negative t over the time constant. So in the case of charging the capacitor, we can effectively look at it like the diagram on the right hand side, because I set the potentiometer to 0 ohms, so it's just going to be 100 ohms, and the LED has a forward voltage of 2.2 volts, meaning that current will only flow through that segment of the circuit once the potential difference across the capacitor has reached 2.2 volts. So I have all of these values displayed right here, and from this we can see that the time constant is 10 seconds and that the expression for voltage is 4.5 minus 4.5 times 10 to the negative t over 10 seconds. So we can validate this by using NVA, and so I created a node between the capacitor and the 100 ohm resistor, and so the current through the capacitor and the current through the resistor is obviously going to be the same. So we just have that first expression under considering node A, and to solve this, we need to use some content from differential equations. So first, we solve in terms of the highest derivative, and from this we can find the homogeneous and the particular solutions. And using that, we can yield that the voltage as a function of time is equal to A times E to the negative t over 0.1 Faradays times 100 ohms plus 4.5 volts. From this, we can find that A is negative 4.5 volts. And finally, we are left with the same exact expression we had before. And an alternate case would be if I set the potentiometer to 500 ohms. So then you'd have 500 ohms in series with 100 ohms. And trivially, we can find that the expression for voltage is the exact same, except for the exponent of E, where the denominator is going to be 60 seconds instead of 10 seconds. So just to summarize our two cases, we have 600 ohms and a 100 ohm case, and we can set that equal to 2.2 volts, since that's the forward voltage of our LED. And so solving for T, we find that with 100 ohms in series, that it's going to take about 7 seconds for the LED to light up fully. And for 600 ohms, we're expecting something around 40 seconds.